Hey guys, so for these ones we are doing general solutions, and one thing that I will say is that these are tough questions. The questions that I have here, okay, they are very easy, but they are very tough. What makes them easy is practice, and what makes them so challenging is lack of practice. So in a sense of these questions, some of the trigonometric tricks you can pull, you can only recognize them if you have done familiar questions, right? If you have done familiar questions, right? Yeah, that's how you will be able to recognize some of the tricks. But if you haven't done anything like we're about to do, it might get a bit trickier, right? It might, I'm telling you, especially as we go on, they get more challenging. So let's start. Oh, and by the way, I just want to say this, just for disclaimer, that you can have one example done in different ways and leading to us having different answers, right? And that is okay, so long as everything that you did was correct. Yeah, as long as you didn't do any mistake, that is fine, right? Good example, I'm gonna show you with this one. The first one, I'm gonna do it one other particular way, and I'm just gonna give a hint of another possible way of doing it, right, which would give you plus or minus different answers. I mean, part of the answers are the same, but let's cook. So you see this one, you see it has cos y, and you know this also has cos y, so you can say cos y will be 2 sine y cos y, then you divide by 2 cos y, 2 cos y both sides. That means this goes this, and all of the cos's and the 2's on the side cancels each other. Therefore you have sine y equals to 1 over 2, right? So you see where we add now. From here you can say reference angle is gonna be sine, right, 1 over 2, which we know it to be 30 degrees. Let me write it here. We know it to be 30 degrees, and therefore you say it was sine we were working with. So where is sine positive? First quadrant, where we have theta being 30 plus 360 k, right, where k is an element of and then where is our thing positive again? Theta. Where is sine positive? It's sine in the second quadrant, where we have 180 minus theta, which our theta is 30, so it's going to be minus 30, 360 k, right? Then you have k is an element of positive, right, integers, and then here of course you now have 150 degrees plus 360 k, right? K is an element of, cool. So this is the answers, but like I was saying, there are many ways of doing it, For example, one person can just be like one person can one person can say, okay, I have cos, let me do this. For this, let me say sine 90, no, yes, let me say sine 90 minus y, right, which of course this gives you cos y equals to sine 2y, of which after this they're gonna say therefore 90 minus y is equals to 2y plus k, 360 k, right, and then k is an element of integers. They can have this, and then from there they just transpose to get y equals to yeah, they can do this, And then from here, because it was sine, they will ask, okay, where is sine positive? First quadrant and second quadrant. So therefore the other one, it will be, you would have 90, right? 180 minus 2y, and then talala talala talala, you see? Yeah. And we can still have another person deciding to go with the one where you're like, okay, I'm gonna change this, so I have cos y is equals to cos 90 minus 2y, right? And now you have cos, right? So you can drop the cos, then you have, right, then you like, where is cos positive? First quadrant and fourth quadrant. That means in the fourth quadrant you'll have something like 360 minus 90 minus 2y, right? Talala talala talala. So like, there's just different ways of doing these things, and if you see me doing it the other way, which might be different from the way you solved it, don't be alarmed. Yeah. Cool. So for this one, right, you already have sine, right? So with that, we can drop the signs and say 3p equals to 2p, right, plus 360 360k, where k is an element of real numbers, integers, bro, right? And therefore you're gonna have, because we have 3p minus 2p, right, equals to 360k, right? And therefore p equals to 360k, which is 0, or we can say 0 degrees plus, right? 0 degrees plus. Yeah. Then where is sine? This is sine. Where is sine? Also positive, second quadrant. Therefore we will have 3p equals to 180 degrees minus 2p, right? Then plus 360k, an element of integers, and then you have p, because 3p minus 2p, that is gonna be p equals to 180 plus 360. Oh no. In fact, I will do it step by step. Plus, right? My mind is still with the not realizing here, so it's gonna change to plus, right? K, I've also forgot the k, and then you have 5p equals to 180 plus 360k, and then you divide by 5, you get 36 degrees plus probably 72 degrees. So now this one is one example that I will say. Remember when we started, I was like, look, some of these questions, if you don't practice, it's gonna be very, very difficult for you to recognize the pattern or the trick, right? This is one of those questions, right? Cool. It's gonna be one of those questions. Just want to show you something. See, sometimes when you have something like this, just say, this is not how we solve it. Actually, you can also solve it this way, because I remember also I used to solve it this way. Yeah, you can. Yeah, I withdraw the statement. You can actually solve it this way. Let tan 2a be x, right? So what does that mean? That means therefore 1 plus x squared equals to 5x minus 5. I transpose, I have 0. I'm gonna have x squared minus 5x plus 1 plus 5, right? So I have 0, I have 6, minus 5x x squared minus 5x plus 6. So I just want to say that. Cool. And then from here I know that it's gonna be x minus 2, it's gonna be x minus 3, right? 0. So therefore x minus 2 equals to 0, or x minus 3 equals to 0, right? And then x equals to 2, x equals to 3. Therefore tan 2a equals to 2, tan 2a equals to 3, right? You see how easy it was, eh? Yeah, so do practice, man, do practice. So here you find the reference angle, right? It's gonna be tan 2, right? And the reference angle is 63.43. For this one, the ref angle equals to tan 3, and the angle is 71.57, right? So therefore you're gonna say, first question, where is tangent negative and positive? No, where is tangent negative? Where is tangent positive? Because it's positive here, bro. So my bad with that. It's positive where? It's positive in the first and the third quadrant, right? And therefore, you know, like in the first quadrant you're gonna have 2a equals to 63.43 plus k 360 degrees. K is an element of a equals to 63.43 right. Then this side we're gonna have 2a equals to 70. Oh no, also have to do, yeah, this side you have 2a, not 2a, yes, 2a equals to 71.57. Don't forget k is an element of real numbers, right? And therefore a will be 35.79 plus 180k, right? Sure thing. Okay, this one is easy. This one is not really, it's not gonna chow your brain, right? Because here it's just expanding these, and let's go. You expand this, you have cos a cos 25, right? So it's gonna be plus sine a sine 25. Then you have a plus cos a cos 25. Then there's gonna be a minus sine a sine 25, right? Which is equals to cos 25. Cool. And then look at this. Look at the minus a sine 25 and plus a sine 25. They're gonna add up to 0. So therefore you have cos a cos 25 plus cos a cos 25, right? Saying what? Equals to cos 25. And this side you have cos A cos 25 cos 25 divided by cos 25 cos 25. You see this one was low-key. Actually, let's also divide by 2. This one, it was quite straightforward. So cos A equals to 1 over 2. And then for your reference angle, it's gonna be cos A being 1 over 2, ne? The angle. Cos is adjacent, so adjacent there. And then the sine 1 over 2, so cos for cos it's adjacent there, 1 over 2, it's 60. Right, so now you can be like, okay, for cos, so it's 60 1 over 2. Cos 60 is 1 over 2. from special angles, cos sine 30 is 1 over 2, cos 60 is 1 over 2. Yeah. And then, therefore, in the first quadrant, you have theta equals to 60 plus 360. K, where k is an element of integers. And then the fourth quadrant, you will have theta equals to 360 minus theta equals to plus 360. Right. 360 k is an element of integers, right? And then therefore you have 300 plus 360k, right? So now they gave us an interval there, so therefore it's not gonna be a general solution here. So what I will do is I want to remove all of these so that we can answer the question. So to answer the question, you're gonna need this, and you're gonna need this, right? Cool. So for this one, let's substitute KB minus 2, ne? So we have 60 plus 360 into minus 2. The angle we are getting is way outside our range, so forget about minus 2. Let's go minus 1. Minus 1, we're getting 300. So we get K equals to minus 1, theta equals to 300, negative degrees. And if it's 0, if we have 0, we have K equals to 0, we have theta being 60. If it's 1, it's 400, which is up outside our range, so we leave it, ne? Cool. Let's come here. So here we have 300 plus 360 K, right? So for K, let's start minus 2, outside the range, minus 1, inside the range. So also for K minus 1, we are getting minus 60 degrees, right? And then 0, we are getting 300 degrees. 1, and if we say 1, right, it's up outside our range. So that means that these four angles are going to be the solution for this problem, because now we have when they gave you an interval, you do this, right? You substitute the values of K to try to find the actual answer away. So the example we're about to do is one of the examples, bro. Trust me, if you don't practice, this one is gonna break you, man. This one is gonna break you. So this is one of the challenging ones. It's one of the challenging ones. So how do we solve this one? Nah, we don't see anything suggesting an identity, because we don't see 2y or 2x, I mean, from either cos or sine. Yeah, well, so it's a bit tricky. It's a bit tricky. But let's say, from cos squared theta plus sine squared theta equals to 1, right? You can actually have cos squared theta equals to 1 minus sine squared theta, and you can say square root of cos squared theta plus or minus square root of right. So cos theta can be equals to plus or minus square root of, you see. Alright, cool. So with this, now we're gonna take it and try to substitute it there, right? Let me see which one works best. Is it the negative or the positive? So okay, for now let me write that. Say I have cos x is equals to 2 minus square root of square root of 3 sine x, right? And now the question is, let's look at this now, which one, because we have a square root here, probably something right would happen. What's the best thing that we can do? Should we use, actually it doesn't really matter, hey, it doesn't matter which one we use, because look at this, because I am thinking I'm gonna take negative just to show it doesn't really matter. 1 minus sine squared x, then I square it. Remember what you do on the left, you also do on the right, so I square this side as well. So now I have 1 minus sine squared x equals to, this is gonna be 4, this is gonna be minus 4 root 3 sine theta, and this is gonna be plus 3 sine squared x. Sorry for that, like in Soto they will say trial of it like elelo. Cool. All right, so right now I'm seeing a 3 sine what, so I'm gonna transpose this to the side. Therefore I have a plus sine squared x, then I have oh no, so it's the sine, this is here, that has already been accounted for, plus 4 minus 1, the 1 when it goes minus, oh no, this is now like 4 because we add them, and then we have minus 4 root 3 sine x, that is plus 3. Cool. So Hamana, here this is where I was like, if like certain things you need to practice in order to be able to recognize them, because this one I don't know how to actually easily explain how you get to factorize this thing, but I hope they will give it loose, ne? Yeah, when you have x squared minus 2, that someone would think someone would think that that is not a difference of two squares, you know. I mean, in a sense, in a way, it kind of looks like it's not, right? But you can make it look like it is a difference of two squares. um yeah, you can make it look like it's a difference of two squares. And how do you do that? hmm? Think about x squared minus square root of 2 and then square. Think about that. It's exactly the same thing as what you have above there, right? And now we can actually say, the difference of two squares. You see, difference of two squares. So, and of course, now when you factorize this thing, you're gonna say this is gonna be x minus and then you have x plus, right? Cool. Let's focus on a different one. Now it's a thing of cool. When you have a when you have x, just make an example, minus square root of 2 squared. When you have something like this, how are we going to multiply here? How are we going to expand this? You know, it's gonna be x squared. You multiply this together and you multiply them by 2, so we have a minus 2 root 2x, right? And then what else do we have? We're gonna have a plus, right? It's gonna be a plus, where from here that is a plus 2. You see, now exactly, it is exactly what? It is exactly this that helps us with this. Because when you look at this, it's the same thing. It's the same thing. You have a 3 there, you have a square root here of 2, right? And you have this gentleman there. So let's break it down now. Let's break it down. Before we break it down, I would like to write this as 2 sine x. I'd like to write it as that squared minus 4 root 3 sine, right, plus 3, right? So now I can actually say that is 2 sine x minus square root of 3, because look at it. When we last part squared, 0 0. Now when we expand this, you say x, you say this thing squared, which is 4 sine x sine squared x, and then you multiply this together, you get 2 root 3 sine x. You multiply by 2, that is 4 root 3 sine x. Then you square this, that is a plus 3. So that means you're gonna have 2 sine x equals to root 3 x equals to over 2, right? And that is going to be what? No, this is sine, this is sine x. And then that means x is going to be what? These things, they remind me of a special angles. Oh no, special angles are, because you have 3, you have a square root of 3, right? And you have 2, and we're talking about sine, so that if it's sine, it's opposite over adjacent. I think x is gonna be 60. X is gonna be 60. Let's see. Square root of 3 2 60, right? And that it is, so you have 60 60 what plus 360. K is an element of real, not real, integers, right? Yeah. And remember, 60 was a reference angle, This is what you'll get in the first quadrant. So in the second quadrant, you're gonna get 180 minus 60 plus 360. Okay. Alright, so you got to 130. Oh, no. 80, 60, 20. 20 degrees. Yeah, that is it. Cool. See you in the next video where we do like, what is this? Where we do exam questions.